Oblique projectile. Our topic is oblique projectile. Oblique projectile. So, this is x-axis. If a body is moving along x-axis, so this is linear motion. So along y-axis also, if it is moving linearly moving along x and y-axis. So obliquely projection is different from linear motion. If we project a body, obliquely, that means it should make some angle theta with the horizontal. So the body is making some angle, that is theta is making horizontally. If we project it with the initial velocity u, so velocity is the vector quantity. It will go up to maximum height. It will reach maximum height, then comes to the ground. So like that, the original path of the oblique projectile, like this. So in last class I explained, so I want to explain one more time here. So this is origin, the velocity vector along this direction. So this is the path of the oblique projectile body. So what happens, u is the vector, so we can write u vector in terms of ux. I cap is the unit vector along x-axis. J cap is unit vector along y-axis. So along y-axis, uy component, j is the unit vector. So I written here the initial velocity component. In terms of ux, uy. The initial velocity vector in terms of ux component along x-axis, uy component along y-axis, I vector unit vector along x-axis, j unit vector along y-axis. So here, so every vector, not this one, every vector, if you know vector chapter, then it is easily you can understand. For example, force. I'm taking here, force is a vector quantity. So the force is acting along x-axis. So if it is acting along x-axis, the component along x-axis will be same, that one only, f only. So component will be that means magnitude, f newtons. If it is acting along y-axis, the force is acting along y-axis, so the magnitude of force is f. So if the vector force is acting, this is a point, the force is acting along this direction. So the force direction, if it is like this force direction is not in the direction of x-axis, not in the direction of y-axis. You just understand what is the vector. Force is a vector quantity. It has magnitude and direction. It has magnitude and direction. That means F equal to 5 Newton. Newton is a unit of force along north direction, like that. Force, we are see what we are saying here, 5 Newton. This is the magnitude. Along north is the direction. The force is acting along north direction. Then magnitude is 5 Newton. So we are mentioning here magnitude and direction. That is, so force is a vector quantity. But if I given in the last list, I explained along x-axis force is there, along y-axis also force is there. But this is it. It is not along the x-axis and it is not along y-axis. So for that one, so along x-axis, the component of force. See, actually the force is acting in this direction. Along x-axis, what is the projection of vector f on x-axis? So if it is making theta, so this magnitude is, so the theta is making with horizontal x-axis. So f will take cos theta. F cos theta component along x-axis, that is nothing but fx. X component of force, that is equal to f cos theta. This one will become, this takes cos theta, this will take sin theta, that is equal to fy comp. So what is here? The force acting, it is not acting along x-axis, it is not acting along y-axis. It is acting in this direction, that force direction, the force vector making with horizontal theta. So along the horizontal fx component is there, along vertical fy component there. So by this, what you have to understand, every vector, if it is making some angle with x-axis, otherwise if it is making some angle with vertical y-axis, we can split the force vector or velocity vector, whatever it is, acceleration vector, whatever it is, any vector, we can split into, we can resolve into two components. F is total F vector, this one, fx component along x-axis into I cap. I cap is a unit vector along x-axis. J cap unit vector along y-axis. So F vector fx I cap plus fy j cap. Initial velocity vector. This is also velocity also vector. So we can write ux I cap uy j cap. So acceleration also we can split into ax ay j cap. So every vector we can split into two components. That means along x-axis component, along y-axis component. Every vector, if it is making some angle with horizontal or vertical, if it is making angle with horizontal, that component will be cos theta will take. Other component will be sin theta. Like that, you just write. You just copy these vector resolution. Here also, this copy the figure. So basic the vector concept I am saying here. Then we can go for oblique projectile. So last class I explained directly oblique projectile. This concept you don't know, that's why you a little bit confused. So I explained now initially only what is vector, how do we resolve along x-axis, along y-axis. Just copy it. Next, see, we can write this vector f vector fxi fy. Fx is nothing but f cos theta into I cap. Fy is nothing but f sin theta into j cap. Okay. Next, velocity vector u cos theta ux. I instead of I write u cos theta instead of ux plus uy. Instead of uy I am writing here u sin theta into j cap. Next, acceleration a cos theta I plus a sin theta j. So see, simply I am resoluting one vector into two components. One vector into I am splitting, I am resoluting into two components, along x-axis component, along y-axis component. We can resolute every vector. What is vector? Vector has magnitude and direction. Vector has magnitude and direction. Like that, we can take one more. Displacement is a vector. So every vector has two components, along x-axis component, along y-axis component. That's why s cos theta along x-axis component, s sin theta along y. See, I cap, this is unit vector along x-axis, j cap, this is unit vector along y-axis. So we can write like this: every vector we split into two components. Okay, along x-axis, along y-axis. Okay, just copy it. Next, so now I'm moving to oblique projection. Obliquely projectile. Obliquely projectile. This is x-axis, this will be y-axis. Is it or not? Yes. So I am projecting a body or a particle, not a body, not a particle. I am projecting with some velocity a body. So the body is moving. So initial velocity velocity is a vector. So the body will move like this, and goes to maximum height, then fall on the ground. So here velocity is a vector. I already now only I explained this just before. U is the vector, so it has components along x-axis, that is ux. This component along y-axis, that is uy. Ux is nothing but u cos theta. Uy nothing but u sin theta. This is the velocity vector. So this vector component along x-axis, that is ux, along y-axis, that is uy. You should remember, along x-axis the unit vector is I cap, along y-axis the unit vector will be j cap. So initially we projected with some velocity, that is u. Okay, velocity vector along x-axis, that is ux, u cos theta, along y-axis u sin theta. We now what we did now, just velocity vector in terms of two components. Okay, so by this information, see, the body projected from here at origin, it falls on the ground at this point. For example, this is point A, this is point A. So the horizontally the projected body displays, how much displaced? OA displacement is there. OA displacement in horizontal axis. How much time it taken from here to here? He traveled this is the actual path. The time taken by the body is t. Time taken by the body is t. So OA is the displacement along the x-axis. So we have the formula: S equal to ut plus half at square. S equal to ut plus half at square. So the displacement along x-axis, the displacement along x-axis. So we can write Sx equal to ux into t plus half into ax into t. Is it or not? Yes. So I kept subscripts along x-axis, s-axis, ux along component of velocity along x-axis, ax component of acceleration along x-axis. So before going to this, the body, for example, here it is there. The body has acceleration always downwards, that is gravitational acceleration. So here a equal to z, that is minus g. So in the projectile motion, acceleration is equal to a equal to minus g, that is minus z in the downward direction. What about acceleration along x-axis? This is acceleration along x-axis, ax. Along ax, nothing is there. Ax equal to 0. So we have ax equal to 0. So just substitute it. Ux is nothing but u cos theta into t plus this term will goes to 0. So Sx equal to u cos theta into t. Sx equal to u cos theta into t. We can write instead of Sx, x also you can write x equal to u cos theta into t. Just you copy it. Next, have you understand this one? Okay. See what I did here. The body is moving like this. The body is moving like this. So I am already I am explaining the velocity direction, that is a vector in the direction it is moving. Every vector has two components. Actually it is I am explaining two-dimensional space. If it is in three-dimensional space, every vector has three components, ux, uy, uz, but I am using here only two components. Projectile, that is two-dimensional space only. So u has ux component along x-axis, that is u vector has y component along uy component, that is u sin theta. So what I want to calculate, the body displaced, how much displacement on x-axis. So this is all displacement along vertical. This displacement on the y-axis. See the displaced from the horizontal. See this. This is the displacement from the horizontal direction to vertical direction. This is a vertical displacement. This will be vertical displacement. How much height it is there, that is vertical. This is the displacement on x-axis. So for that one, we have the s equal to ut plus half it square. Already we know the formula. So along x-axis, that's why I kept subscript sx equal to ux into t plus half ax into t square. A equal to minus z along y-axis only, vertical direction, downward direction only, a equal to minus z. That is ay equal to minus z. Ax equal to along horizontal direction, nothing. It has no acceleration. So ax equal to 0. You have horizontal displacement equal to u cos theta into t. U cos theta into t. Okay. Based on one we calculated Sx equal to u cos theta into t. See, after time t, for example, after a time t, maybe it is there, the body if at this position, this is a point here, for example, at this position. So what is the final velocity of the body? Final velocity of the body. We have the equation v equal to u plus at. So the body is moving above the ground. The body is moving above the ground, then it is in projectile. So we can apply along vertical displacement, vertical Vy equal to Uy Ay. Okay. So velocity along y-axis after time t, that is equal to Uy is nothing but u sin theta minus Ay equal to minus gt. So velocity of the projected body after time t. What is the final velocity after time t? After time t, what is the velocity of the body? U sin theta minus gt. You have to write this one also. Velocity of the body after time t at point B. What is the velocity? Initially it has u sin theta in vertical direction. After that, after time t, u sin theta minus gt. That means velocity is decreasing. Velocity is decreasing. Initially it has u sin theta component initially, but after that it is decreasing. Minus gt is coming. Minus negative term is coming. Minus gt. You have to write this one also. See, I explained displacement along x-axis, velocity after time t. Okay, in vertical. Next. Next. So we calculated displacement along x-axis, velocity after time t in vertical direction. So I'm going to calculate Sy. Displacement of the projected body in vertical direction. Vertical direction, what is the displacement after time t? So we have the formula S equal to ut plus half at square. Along vertical means along y direction. Sy equal to uy into t plus half ay into t square. So Sy equal to Sy only. Uy is nothing but u sin theta into t, ay minus of gt square. This is the displacement along vertical direction. This is the displacement along vertical direction, Sy. We can say Sy is nothing but y along y on the y-axis. The displacement on the y-axis, that is u sin theta t minus half gt square. Already we calculated Sx, that is x u cos theta into t, that is L on the x-axis. So displacement is also vector. So displacement also we can split into two components, along horizontal direction, along vertical direction. Displacement covered by the body along vertical direction, u sin theta t minus half gt square. How it has come? I use this one, ut plus half at square. Sy y y y. Sy uy ay. Uy is nothing but u sin theta, ay equal to minus z. Is it or not? Yes. Next. So up to now we calculated Sx, Vy, Sy. Is it? Next. One more term I want to introduce to you. Time of flight. Time of flight. time of flight. So time of flight is t, capital T. See, time of flight is nothing but, so this is x-axis, this will be y-axis. I projected a body with some velocity u. After projection, the body is moving like this. So my question is, it started its journey at time at the origin, finally reached a point A. How much time taken by the projected body to reach the ground? That means in the whole journey, how much time, the total time taken by the body of its total journey, that we can say T. That we can say T. So that means this displacement along vertical only. The displacement along the on the y-axis only, vertical displacement only. See, that means it is more above the horizontal, axis only it is moving. So we have to calculate sy uyt plus half ayt square, half ayt square. Displacement covered by the body along y-axis, that is sy equal to uy into t plus half ayt square. So see, along x-axis we got u cos theta into t, along y-axis sy we got in terms of y component we got, but resultant displacement along y-axis is 0. It is not displacing on the y-axis. So uy equal to u sin theta into t minus, so the time taken is keep capital T, half gt square, u sin theta into t minus half gt square equal to 0. So u sin theta into t equal to half gt square, t gets cancelled, t equal to 2u sin theta by g. So this is time taken by the total time taken by the body in projectile motion. So t equal to 2u sin theta by g. See, we taken displacement on the y-axis, it is 0. Displacement along the x-axis is u cos theta into t. Displacement on the y-axis, that is equal to 0. Okay, you just use 2u sin theta by g, that is time of flight formula. 2u sin theta by g, that is okay. Up to now it's okay. Tomorrow I will give some more explanation. 2u sin theta by, that is time of flight. So today I given sx, well, displacement along x-axis component, displacement along y-axis component. Next vy, time of flight, These things I explained in projectile motion. Thank you.